Good morning, children. The last topic in this lesson, quadrilaterals, is the midpoint theorem. The midpoint theorem is a property that is related with triangles. Consider triangle ABC. If D and E represents the midpoints of AB and AC, if you join DE, you can see two conditions here, or you can arrive at two conclusions. The first conclusion is the line DE will be parallel to BC, and the second condition will be DE will be half of BC. That means midpoint theorem states that a line segment joining midpoints of any two sides of a triangle is parallel to the third side as well as half of the third side. The midpoint theorem states that a line segment joining midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. Equal to half of it. So that is the statement of midpoint theorem. In a triangle, a line segment joining midpoints of any two sides is parallel to the third side as well as equal to half of it. You need not study the proof. You need to know only the statement. What will be the converse of this statement? Imagine a triangle ABC and D is the midpoint of one side AB. That means in triangle ABC, D is the midpoint of the side AB. You draw a line parallel to BC through D, and that parallel line will touch the side AC at E. So what will be the point E? The point E also will be the midpoint of AC. So in triangle ABC, D is the midpoint of side AB. One more condition, DE parallel to BC. Then immediately E also will be the midpoint of AC. Then E is the midpoint of AC. That means you will be given only the midpoint of one side. You can draw a line parallel to the second side through that midpoint. That line meeting the third side, that point will be the midpoint, or the line is bisected by that point at the point E. So what will be the converse statement? The converse statement will be in a triangle, a line segment through the midpoint of one side parallel to the second side, what it does, it bisects the third side. So the statement of midpoint theorem as well as converse is required in the next exercise. Exercise 8.2, question number 1. ABCD is a quadrilateral in which P, Q, R, S are the midpoints of AB, BC, CD and DA as shown in figure 8.29. AC is a diagonal. Show that the first condition, SR parallel to AC, SR equal to half of AC, PQ equal to SR, and the third PQRS is a parallelogram. So ABCD is a quadrilateral and the midpoints of the sides are given to you. ABCD is a quadrilateral. P, Q, R, S are the midpoints. PQRS is joint. And the diagonal AC is also given as a diagonal. The first part to prove is SR parallel to AC and SR is equal to half AC. So pick out the triangle in which the midpoints of any two sides are given. The triangle concerned is ACD. So the proof starts as in triangle ACD, S and R are the midpoints of AD, DC. Therefore, SR parallel to AC, SR is equal to half AC. You can write here midpoint theorem. Since you are writing in detail which are the midpoints and sides, you can just mention as midpoint theorem. So that is the first part of the proof. Now the second part, you have to prove that PQ is equal to SR. For that, take the next triangle ABC. In triangle ABC, P and Q are midpoints of AB and BC. Therefore, PQ parallel to AC, PQ is equal to half AC. That is also by the rule of midpoint theorem. You have to prove that PQ is equal to SR. Now, SR is equal to half AC, equation number 1. Again, PQ is equal to half AC, equation number 2. Therefore, PQ is equal to SR. Similarly, SR parallel to AC and PQ parallel to AC shows that PQ parallel to SR also. What is the condition here? Two lines parallel to a given line, are parallel to each other. That is, PQ is equal to SR, PQ parallel to SR. In quadrilateral PQRS, the same pair of opposite sides are parallel and equal. Therefore, PQRS is a parallelogram. That is the third part to prove. In quadrilateral PQRS, since PQ is equal to SR and PQ parallel to SR, PQRS is a parallelogram. The reason is since one pair of opposite sides are parallel and equal. This proof is a very important 3-mark question. It's a 3-mark question which can be asked in any of the exams. Question 2. ABCD is a rhombus, underline the word rhombus, and PQRS are the midpoints of AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rectangle. Given that ABCD is a rhombus, what are the properties of a rhombus? In a rhombus, all sides are equal as well as the diagonals bisect at right angles. So what we have to prove is PQRS is a rectangle. So the picture ABCD is a rhombus. P, Q, R, S are the midpoints of AB, BC, CD and DA. What we have to prove is PQRS is a rectangle. If you have to prove PQRS as a rectangle, first you should prove as a parallelogram and then a parallelogram with any one angle 90 degree. Any parallelogram to prove as a rectangle, any quadrilateral should become a parallelogram, and then parallelogram one angle is 90 degree. So first our logic is to prove that PQRS is a parallelogram. For that, join any one diagonal AC. So the proof as we did in the previous problem, in triangle ABC, P and Q are midpoints of AB and BC. Therefore, PQ parallel to AC and PQ is equal to half AC, equation number 1, and the reason is midpoint theorem. Similarly, in triangle ADC, S and R are midpoints of AD, DC. Therefore, SR parallel to AC, SR is equal to half AC, equation number 2. From 1 and 2, PQ parallel to SR and PQ is equal to SR. Therefore, PQRS is a parallelogram since one pair of opposite sides are parallel and equal. So this will be the basic of all the remaining questions. First is to prove that PQRS is a parallelogram. Now we have to prove that any one of the angle in QRS or P has to be 90 degree. Let us join the diagonal BD also. In a rhombus, the diagonals bisect at right angles. So, in a rhombus, diagonals bisect at right angles. Therefore, let's mark any one angle. Angle 1 is equal to 90 degree. PS parallel to BD. Therefore, a part of it PM is parallel to ON also. PM parallel to ON. Similarly, PQ parallel to AC or a part of it PN parallel to OM. Therefore, the quadrilateral PMON, therefore, quadrilateral PMON is a parallelogram since both pairs of opposite sides are parallel. Now, what is the condition regarding the opposite angles of a parallelogram? Opposite angles are always equal. So, if angle 1 is 90 degree, what will be angle P also? Therefore, angle 1 is equal to angle P is equal to 90 degree. Opposite angles of a parallelogram. Hence, how do you give a conclusion? PQRS is a parallelogram. With one angle as 90 degree. Therefore, PQRS is a rectangle. Question number 3. ABCD is a rectangle. Underline rectangle. We can use the property of the opposite sides of a rectangle are equal and all angles of a rectangle are 90 degree. and PQRS are the midpoints of AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rhombus. How do you prove any quadrilateral as a rhombus? Any quadrilateral, first we have to prove it as a parallelogram, then one pair of adjacent sides, if they are equal, you can prove that quadrilateral as a rhombus. So, the first logic is to prove that PQRS is a parallelogram. So, that the proof in triangle ADC, S and R are midpoints of AD and DC, therefore SR parallel to AC and SR is equal to half AC. In triangle ABC, P and Q are midpoints of AB and BC, therefore PQ parallel to AC, PQ is equal to half AC. Both the reasons are by using midpoint theorem. So from 1 and 2, PQ parallel to SR and PQ equal to SR, therefore PQRS is a parallelogram since one pair of opposite sides are parallel and equal. Now we have to prove that any one pair of adjacent sides are equal. For that, we have to take any two triangles in which PQ and PS are forming the adjacent side. Which are the two triangles? In triangle APS and BPQ, and now P is the midpoint of AB, therefore AP is equal to PB is already given here. Angle 1 is equal to angle 2 90 degree because ABCD is a rectangle and so each angle is 90 degree. We need to get one more corresponding parts, that is AD is equal to BC and half AD is equal to half BC. Half AD can be taken as AS, half BC can be taken as BQ because S and Q are midpoints of AD and BC. So the triangles can be proved as congruent. So let's take first the part AD is equal to BC, opposite sides of a rectangle. Therefore, half AD is equal to half BC, or half AD can be taken as AS is equal to BQ since S and Q are midpoints of AD and BC. Now you can prove the triangles are congruent. In triangles APS and BPQ, AP is equal to PB since P is the midpoint of AB. Then angle 1 is equal to angle 2 is equal to 90 degree. Angles of a rectangle. And the third condition is AS is equal to BQ proved. Therefore, triangle APS is congruent to triangle BPQ by side angle side by SAS. PS is equal to PQ CPCT. And how do you give the conclusion? Since PQRS is a parallelogram with one pair of adjacent sides equal, it is a rhombus. Is that rhombus? Question 4. ABCD is a trapezium in which AB parallel to DC, BD is a diagonal and E is the midpoint of AD. A line through E parallel to AB intersecting BC at the point F show that F is the midpoint of BC. By reading the question itself, you can understand it is the application of converse of midpoint theorem. ABCD is a trapezium in which AB parallel to CB, and then E is the midpoint of AD. E is the midpoint of AD. A line through E parallel to AB. We have drawn a line through E parallel to AB and it meets BC at F. It meets BC at F. What we have to prove that F is the midpoint of BC. So here, to understand very clearly, the converse of midpoint theorem is applied for triangles. So pick out the triangle in which the midpoint of one side is given and through the midpoint a line is drawn parallel to the other side. The triangle is triangle DAB. If you take triangle DAB, in triangle, the proof states, in triangle DAB, E is the midpoint of AD. First condition. Second condition, let's plot this point as G, EG parallel to AB. Therefore, G is the midpoint of DB. The concept is converse of midpoint theorem. Converse of midpoint theorem. That is, a line through the midpoint of one side parallel to the second side bisects the third side. Now, which is the triangle you are going to take? The triangle will be triangle DCB. In triangle DCB, the same converse of midpoint theorem will be applied in triangle DCB. G is the midpoint of DB, comma, GF parallel to BC, because AB and BC are already parallel. Therefore, F is the midpoint of BC, again by converse of midpoint theorem. This is an important 2-mark question, or it can be asked in the 3-mark section also. Either a 2 or 3-mark question. The remaining questions we will do in the next class.